Now that we've talked about vertical asymptotes, we're going to talk about horizontal asymptotes. And each rational function could have at most one horizontal asymptote, and it's the line. It would be a horizontal line that the y values approach as x goes to infinity or negative infinity. So kind of if you zoomed out on the graph, as you went out to the right and the left, what's happening to the y value? So maybe the graph is doing something like this. And what's important is as we go out to the left and right, it's kind of leveling off to this this y value. And that horizontal line, which will look like y equals something, would be our horizontal asymptote. Now, all of this comes down to the degree and the leading coefficients of our polynomials. Okay, so the first thing that could happen is that the degrees of the numerator and the denominator could be the same. Okay, so we could do something like, I'll do an example here. Maybe we have f of x equals 3x squared plus 2 over 5x squared minus 3x plus 1. Okay, so the degrees are the same here. And up here it said let a be the leading coefficient of p of x. So here it would be 3. And let b be the leading coefficient of q of x. So that would be our 5. And here it says if p of x and q of x are of the same degree, then the line y equals a over b will be the horizontal asymptote. So for our example here, we would say y equals 3/5. So if the degrees are the same, you'll always take those leading coefficients. Now next, if the degree of the top is less than the degree of the bottom, so for example, if we had f of x was equal to 3x squared plus 2 over x cubed minus 1, so the degree of the top is smaller, then the rule is that y equals 0 will always be the horizontal asymptote. So here, our horizontal asymptote would be y equals 0. And then the last case, if the degree of the top is bigger than the degree of the bottom, so for example, if we had f of x equals x cubed plus 1 over 3x squared plus 2, okay, then the rule is that there is no horizontal asymptote. So you could just say no horizontal asymptote or none. Okay, so you look at the degrees and then you use these 3 rules to decide what the horizontal asymptote is. Okay, let's actually do some examples of finding horizontal asymptotes. So for number 8, we have f of x equals x squared over x plus 3. So here the degree of the numerator is higher than the degree of the denominator. So we don't have a horizontal asymptote. We could just say no horizontal asymptote. Okay, number 9 here, g of x, we have 4x squared over x squared plus 2. So the degrees are the same. So we just take the coefficient, which this would be like 1. So we would just have y equals 4. And for number 10, we have h of x equals x over x squared minus 16. So the degree of the numerator is smaller than the degree of the denominator. So we get y equals 0.